Okay, today's lesson is on collinearity, betweenness, and assumptions. First up is collinearity. Points that lie on the same line are what we call collinear, while points that do not lie on the same line are called non-collinear. So if I asked you which group of 3 points were collinear and which group of 3 points were non-collinear, hopefully you would guess that A, B, and C were collinear and D, E, and F were non-collinear. Obviously A, B, and C are collinear because they are on the same line. There's a line drawn through them, so you know that they're collinear. If there is no line drawn, or it's really apparent that they're not on the same line, you would say that they're non-collinear. So again, you have to see that line there to know that they're collinear. If you have 3 random points, let's say I had a point here, point there, and a point there, and this was A, B, and C. If I don't have that line through, you can't assume that they're collinear. It's got to have the line. So keep that in mind, make a note to yourself about that. Okay, so like in the diagram below, if I asked you if R, S, and T were collinear points, here's R, here's T. All 3 of those points are on a line, so they would be collinear. If I asked you if P, O, and X were collinear, again, all 3 are on the same line, so they would be collinear. If I asked you if M, O, X, and Y were collinear, they're obviously not on the same line. M's way up here, so they would be non-collinear. Okay, and that kind of brings us to betweenness of points. Now for a point to be between 2 other points, all 3 or more of the points must be collinear. So if I said, is T between A and R? Hopefully you would say, yes, T is between A and R because I've got 3 points, I've got a line connecting them. So T is between A and R. Now, if I asked you if O is between X and Y, no, O is not between X and Y because 1, there's no line drawn, and 2, it's obvious that you couldn't draw a line anyway. So they are non-collinear. And we can use that information to talk about triangle inequality. Now, if I give you 3 points, there are only 2 possibilities of what those 3 points could be. One would be that they are collinear, meaning you have, let's say, A, B, and C. B is between the other 2 because they lie on the same line, and 2 of the distances add up to the third one. 5.5 plus 12.5 equals 18. The other option is that they are non-collinear. The 3 points determine a triangle. So if I have the 3 points here, obviously not collinear, so they would actually make a triangle when you connect the segments. Okay? Now up here, notice we have an equation. Okay, an equation, you've got the equal sign. This is an inequality. And if you remember from algebra, this means that 14 plus 11, so this side plus this side is greater than this side. And this is an example of a really important characteristic of triangles. The sum of the lengths of any 2 sides of a triangle is always, let me underline that, always greater than the length of the third. Okay? So again, another note you might want to make yourself. Anytime you see something in red here, chances are it's something that's important, it's vocabulary, it's an important thing that I want you to know. Okay? And lastly, assumptions from diagrams. In geometry, there's going to be a lot of diagrams in your books, and it's important to know what you can and cannot assume from looking at a diagram. I kind of touched on that in one of the last classes, that even if you had something that looked like this, you can't automatically assume that it's a right angle. So I've got a chart below that you might want to copy down word for word in your notes and keep handy. Basically things that you can or should assume and things you should not assume. Straight lines and angles, that's okay to assume. There's, if I draw a line like this, you can assume that that's a straight line. If I draw this, you can assume that that's an angle. What you cannot assume, again, is right angles. Collinearity of points. If I put 3 points on this line, you can assume that they're collinear. If I draw 2 segments, like so, even though they look like they're identical in length, you can't assume that they're congruent. You can assume that points are between other points. Because these 3 points are collinear, you can assume that this point here is between this one and this one. Okay? What you can't assume is congruent angles. For example, if I had this angle and this angle, even though it's not perfect, but if they looked identical, unless I told you they were, you can't assume that they are. So again, unless you're given that, don't assume that angles are equal. And then the relative position of points you can assume. Okay, and I'll kind of give you an example of that on the next page. What you cannot assume is the relative size and measurements of segments and angles. If I say that this is 10 and I draw another one that's about half as long, you can't assume that that's about 5. Just because it looks like it, you can't assume it. So start getting out of the habit of that now, please. So here's a good example. I've got this diagram here, and all I'm given is this diagram. So what can we assume? Okay, we can assume that ACD and BCE are straight lines because they're drawn as straight lines. We can't assume that BAC is a right angle. There's no little box here. I just put it there, but there's, originally there's no box showing that it's a right angle, so we couldn't assume it unless that was there. We can assume that BCE is a straight angle, or line again. What we cannot assume is that CD is congruent to DE. I know it doesn't look like it here anyway, but even if they did, you can't assume it because it's not given. You can assume that C, D, and E are non-collinear because it's very obvious the 3 points are not on the same line. You cannot assume that angle B and angle E are congruent. They look like they are, but that doesn't necessarily mean that they are because, again, it's not given. You can assume that C is between B and E because, again, those 3 points are collinear and C is right in between them. You can't assume that CD and E is an obtuse angle, just like you can't assume it's acute, or you can't assume that it's right because there's no measurement given here. You can't assume that E is to the right of A because it very obviously is. What you cannot assume is that BC is longer than CE. So that's kind of an example of things that you can and can't assume, and if you have your diagram, you'll get it. You'll get the hang of it. You'll be able to tell just by looking at it, and it'll be ingrained in your memory. Okay, so these are things that it's okay to assume, things that's not okay to assume. I know this is a fairly easy lesson, so that's good. Hopefully it's easy for you to understand. Be prepared for a 3-question video warm-up quiz when you come to class next on Monday, and we will be good to go, or whatever day we happen to do the quiz. Okay, thank you very much.